Let's graph a tangent function. We want to graph y equal tan 2x. One thing to note about the tangent function right away is that the period, if the coefficient of x is 1, is pi. The period of this particular tangent function then, to calculate its period, is found by taking pi and dividing by 2. Remember that the tangent has vertical asymptotes and that a pair of vertical asymptotes then, or each pair, is pi over 2 units apart. So let's draw ourselves a coordinate system to graph this tangent function. There's an x-axis and a y-axis. And I need to think about if I have a set of vertical asymptotes that are centered around the y-axis that are pi over 2 units apart, what would be the location of them? Let's say one of them's here, one of the vertical asymptotes is there, and one is here. Each of them is at pi over 4 units from the y-axis. So at negative pi over 4, because pi over 4 plus pi over 4 is pi over 2. So here's one vertical asymptote. Here's another vertical asymptote, and then that pattern continues. As you know, tangent's periodic. The other things to note about tangent, we found the location of a pair of asymptotes are that the tangent goes through the horizontal axis exactly halfway between the asymptotes. In this first half of one period, say at negative pi over 8, that's supposed to be halfway, the tangent will have value negative 1, and so that's negative pi over 8. At 3 pi over 8, the tangent's value will be positive 1, and then I can draw a piece of the tangent, one period of it actually, between this pair of asymptotes. Now the pattern continues, so if I were to go, say, just pi over 4 units, half of a period, I know that I would get this piece of the tangent again, something like that's supposed to look like that piece. And if I go pi over 4 units this way, I get the other sort of part of the tangent, and then that continues in each direction. Well, it's not a bad idea to think about labels on your axes. Let's go back to that graph for a minute. This particular vertical asymptote's negative pi over 4. If I go between 0 and negative pi over 4 exactly halfway, that's negative pi over 8. Then 0, then positive pi over 8, and then positive pi over 4, and so forth. Let's graph a tangent function. We want to graph y equals negative 3 tangent 1/2 x. So here's the thing we want to graph. Remember that the tangent, if the coefficient of x is 1, has period pi. So the period of this particular tangent function is going to be pi divided by 1/2, which is 2 pi, which means a set of vertical asymptotes for this tangent need to be 2 pi units apart. Other things to note are this negative is going to reflect this tangent function over the x-axis. The 3 we'll use as we're graphing and plotting some points. So we want to start by drawing a coordinate system to graph this in an x-axis and a y-axis. From there, I want to draw a pair of vertical asymptotes, and I'm just going to choose locations for them and then label them accordingly. So here's a vertical asymptote, and here's a vertical asymptote. That pair of asymptotes are 2 pi units apart. So each half is pi units, which means the one on the left is negative pi, the one on the right is positive pi. Now halfway from 0 to negative pi is going to be negative pi over 2, and halfway between 0 and pi is positive pi over 2. I'll label those in a minute, but I want to use those to plot some points, keeping in mind that this is negative and 3. So at negative pi over 2, the tangent's going to have value positive 3, because it's, remember, reflected about the x-axis. At positive pi over 2, the tangent will have value -3. And then I can draw in, and again it contains the origin, I can draw in my tangent containing those. I have to be careful to draw it going through the origin and then going and getting close to its vertical asymptotes. Now let me label the axes -π/2, +π/2. Let's graph a cotangent. We want to graph y equals 1/2 cotangent 2x. Remember that the cotangent has period pi just like the tangent does when the coefficient of x is 1. This particular cotangent's period is going to be pi divided by 2, this 2 right here. That means that between a pair of vertical asymptotes are pi/2 units. We'll use the 1/2 as we get ready to graph the cotangent to help plot points. So let's start by drawing a coordinate system and locating some vertical asymptotes for this cotangent. So here's a coordinate system. This particular cotangent has vertical asymptotes at 0, which is the same as the y-axis. And it has a vertical asymptote at pi. Well, actually, I should say at pi/2, because a pair of vertical asymptotes are pi/2 units apart. So I'm going to locate that asymptote at some place on the x-axis, and then I'm going to label it pi/2. Now I'm graphing the cotangent. The cotangent in general is decreasing, or throughout its domain is decreasing. It contains a point on its horizontal axis right in the middle, and then in the first half of one pair of vertical asymptotes, this particular cotangent will have value 1/2. So if I call this 1 unit, a half is about there. In the second interval, second half between a pair of vertical asymptotes, it also should have value -1/2, I should say, not the same as 1/2. And then I need to draw the cotangent with a smooth curve. So let's see what we can do to come up with one period of this particular cotangent. I think I'd like to label the horizontal axis. If that's 0 to pi/2, this should be pi/4. And again, these are -1/2, +1/2. Let's graph a tangent function. We want to graph y equals 2 plus tan x. Remember that the tangent has period pi if the coefficient of x is 1, and so the period of this tangent will be pi. When I have 2 plus the tangent, I need to shift that inflection point for the tangent, that horizontal axis, to 2. So keeping that in mind, let's draw ourselves a coordinate system to graph this in, an x and y axis. And I need to come up with some vertical asymptotes. The tangent has period pi. Its vertical asymptotes are symmetric about the y-axis. So I'll locate one of them there, and I'll locate one of them here. The values of these are -π/2 and +π/2. And I can draw some more sets of them if I go exactly pi units from pi/2. I get another vertical asymptote, and that will be at 3π/2. And going pi units to the left, I'll be at -3π/2. The other thing to keep in mind as we get ready to draw the tangent is that there's this vertical shift of 2 units. So if I go in the y direction to 2 at 2, and I'm going to start by drawing the middle one period of this tangent. At 2 is where I want to have my tangent inflect. So halfway through this particular piece, I'm 1 unit below 2, and halfway through that, I'm 1 unit above 2. I'm going to try to draw the tangent, inflecting there, and then curving up. And that's one period of the tangent. I want to try to repeat that and draw a couple more periods of the tangent. You can see I'm using similar points as those I used within the first period. There's a second period of the tangent, and then doing that one more time, here's the horizontal inflection point, and here's another period of the tangent. And you get the idea that it is periodic and it repeats itself every pi units between negative pi over 2 and pi over 2. Well, that's how the graph looks by hand. It might be interesting to see how this one looks on a graphing calculator. So, if we look at a graphing calculator, what we'll want to do is go to y equals, and we'll want to enter 2 plus tangent x. And there's a couple of mode options you want to think about when you're graphing. So I'm going to look at mode. In this particular one, I want to make sure I'm in radian mode. And I've set the calculator here, let me indicate. I've set it in dot so that you won't see the vertical asymptotes, or the calculator won't try to draw the graph connected. Now I've set a window that'll work for us. What I've put here, this negative 1.57 is actually negative pi over 2. 1.57 is pi over 2. And you can see the other values that I've used to graph this tangent. And let's take a look at the graph. There's 2 plus the tangent. It's interesting. Let's go back to y equals and compare that to the graph of tangent x. So you can see exactly what the 2 plus tangent, or how the 2 plus tangent compares to tangent. So I'm going to push graph again. And you can see there's the tangent, and the others clearly 2 units shifted vertically from that. Let's graph a cotangent function. We want to graph y equals negative 2 minus the cotangent of x minus pi over 4. Well, one thing to note is that this is cotangent. Its period, this particular one's period is pi because the coefficient of x is 1. This negative is going to reflect it across the x-axis, so it's going to look in shape similar to the tangent. The negative 2 is going to shift its horizontal axis down 2, and this minus pi over 4 is going to shift it horizontally pi over 4 units to the right. So let's draw some axes, and keeping in mind that I got to shift it down 2 units, I probably should have drawn my x-axis a little higher, but we'll work with what we got. So here's the y and the x-axis. Now, I want to shift it vertically down 2. So I'm going to draw myself a dashed horizontal line here that will be the horizontal axis for my cotangent. Now the cotangent's vertical asymptotes, keep in mind the vertical asymptotes without this horizontal shift, would be at 0 and at pi. But I want to shift the vertical asymptotes pi over 4 units to the right. So I know I need a pair of vertical asymptotes. And let me go ahead and label pi on my axis, and then there's pi over 2, and use those. Here's some tick marks representing quarters of pi, because a pair of vertical asymptotes for this are going to be at pi over 4, which is pi over 4 units to the right of 0, and at pi plus pi over 4, which is the second vertical asymptote that I'm drawing, and that's at 5 pi over 4. So here's the horizontal axis, and the cotangent inflects right halfway between the pair of vertical asymptotes. Its coefficient is negative 1, so it's going to be drawn as an increasing graph. I'll say that there's a point for the cotangent here, which is 1 unit below its horizontal axis and halfway within the first half of a pair of vertical asymptotes. And then using a similar point, I can draw a single period of this particular cotangent graph. And there we go.
Determine an equation for the graph. And when we look at the graph, it does look like a graph of a tangent function passing through the origin. The thing is, it's the tangent function reflected about the x-axis, because normally for the value pi over 4, it would be up at positive 1. but it's actually down at -2, which tells us that it was reflected and that the amplitude, or it has been stretched, I should say, by a factor of 2. So what that means is that the equation for this graph would be y equals negative for the reflection, 2 for the stretch, and then simply tangent of x. So y equals -2 tangent of x. Let's do another example of finding the equation of a graph. Determine an equation for the graph. When we look at this now, this one looks more like a cotangent graph, which has been vertically translated down. And also because we see that this one cycle occurs from 0 to pi/2, the period has been changed. Instead of the normal period of pi, we have half of it, or pi/2. So what we would have then is y is equal to, because it's been translated down 1 unit, -1, plus the cotangent of 2x, which occurs, the 2, which is the value for b, would then give us the correct period of pi/2. So y equals -1 plus cotangent of 2x.